Alright, welcome to section 8.7 of Unit 9, Algebra 1B. And we are going to start off by looking at page 61. So if you turn to page 61, you will see several rules at the bottom of the page. One of them says this: a to the mk, m over k, and then it's the same as a to the m power k root. So this is a little property that we're going to be seeing. We're going to be seeing several properties, but this first one, all it's saying is this: if you have some number to a fractional power, say 3/8, for example, what you want to do is keep the big base and the top power inside of a square root. So it looks like this, 5 to the third. And then this denominator is going to become the root down here. And they can be converted back and forth one way to the other like this. And the one on the left is called the exponential form. And the one on the right is called the radical form. So we're going to be swapping from one to the other one and vice versa. All right? All right, so go ahead and turn the page now in your packets. And we're looking at, in your Unit 9, page 63. Let me enlarge this, see if we can make it fit. All right, page 63. Slice this up a little bit. And we'll start off with number 2, because we'll go with the even ones, and I'll let you try the odd ones on your own. Here we go. Number 2 says this: we have the square root of 13. Now, whenever you have a square root, whenever there is a square root, there is an invisible 2, but we don't write it. It's right there. And the 13 inside has an invisible 1 power. So they want you to rewrite this using exponential form. So here's what you're going to do. You're going to write 13 to the first power, just like it's there. And then this 2 is going to go down here as the denominator of the power. So it's really 13 to the 1/2 power. Number 4. Take a look at number 4. Once again, I have an invisible 2 power. Now, if it helps you, go ahead and write it in just like I did right now, so that you can remember to rewrite this as 22 to the 3/2 power. Because remember, the denominator is the index, or the root, that is outside. Number 6. Now I have an x squared and I have a y squared. Notice that I have a 3 root, or an index of 3 outside. So I need to make a denominator for both of them. Each one gets a 3 in the denominator. Okay, so here we're going from radical to exponential. If you look down your page to number 8, these we're now going vice versa. The other way, we're going to go from exponential and we're going to write it in radical. So our answer is going to be a square root, or a radical. And here's what happens. I keep the b to the first power inside, which is just b. And I'm supposed to write this 2 out here. But technically, you don't have to write it, because just by having a square root by itself, it's already implied that there's a 2 right there. So our answer could be just this. That means exactly the same thing. All right, number 10. Let's see if we get this. This is what we have to begin with. Remember that you are going to keep the base and the top exponent together, and then you're going to write a square root, and the denominator is what goes out here. It's a tiny little subscript. Don't make them too big. It's not supposed to look like this. All right, the 5 is not supposed to be huge like that. It's supposed to be tiny little subscript right up here. All right, or actually a superscript should be. Number 12. What happens with number 12? There's a negative in front. Well, all you need to worry about this negative is that the answer is going to be negative. The 10 to the 1 power is just 10. And then this 2 is an invisible square root, or the little invisible 2 index up front. Okay, so that's number 12. And then we're going to do one more, bottom of the page, number 14. Let me enlarge this. And here it is. Okay, number 14. So to begin the problem, I have b to the 5/10 power. Now I can reduce this. This right here can be reduced to power, because that fraction can be 1/2. And if it's 1/2, that means I keep the b, and then I write the square root, and this 2 is invisible right here. You don't have to write it. I'm writing it so you can see where it should go, but you don't have to write it. Okay? Okay, let's go ahead and turn the page. Going to number 16. Number 16, kind of small here, a little difficult to see. But what we have, I'll go ahead and rewrite it for you, is 7 to the 3/9 powers. 7 to the 3/9 powers. Just like we did with number 14, we're going to reduce this 7 to 1/3 because 3 and 9 can both be divided by 3. And then, if you're getting the hang of it now, this is what stays, the 7. Then you write a square root or radical, and this will be your index. Your root will be the third. So it's really a cube root or a third root. And that's your answer. Number 18. What does number 18 say? Let's see, we have x to the 1/2, and then all of that to the 4/5 powers. So what you're going to do is you are going to multiply this. The 4 and the 1 multiply, the 2 and the 5 multiply, and here's what I get, x to the 4/10. And then we do the same thing we did on number 14 and number 16, which is to reduce the power. The exponent reduces to 2/5. And finally, I need to change it to the radical form, which will be square root x squared, and then this underneath the denominator goes outside as a root. Very good. Number 20. See if we can get a couple more. Let's see. For these kinds of problems, what you want to do is add the powers. And the rule for this is explained in your unit on page 62. So if you go back 2 or 3 pages, you will see the rules at the top of the page, top of page 62. In the box, there are 3 rules. One of these rules is this, where you're going to add these exponents. Before you can add 1/3 plus 2/9, you need a common denominator. I need to multiply this first one by 3, so that both denominators will be the same. And then I can add the denominators, and that is my exponent. So I have a to the 5/9. And then my final step is to change this into radical form. Keep that part, the a to the 5th, and then it's a 9th root outside. Okay. Okay, let's see if we can get 2 more problems in. Number 22 says the following. X to the 7/10 plus a negative 1/2. Once again, we're trying to add these. So I'm going to multiply these both by 5. So I get 7/10 plus a negative 5/10. 7 and minus 5 will be a 2/10. So we got x to the 2/10, which reduces to x and 1/5. X to the 1 is just x, and then you have a 5th root outside. All right. And then number 24, this may be the last one that we do together. Y to the 2/3, 1/2, and then 3/5. What you need to do here is just multiply all the top numbers. 2 times 1 times 3, 3 times 2 times 5. 2 times 1 times 3 is going to give you 6 on top. 3 times 2 times 5 on the bottom is going to give you 30. And that can reduce by 6 to give you 1/5. And then you're going to write this in radical form. Keep the y. 5 is the root, the index. Alright, that is number 24. Go ahead and try all the odd numbers. And if you need some help, like always, you can come into the center and get some help. Alright, bye-bye.